Dear children, today we are going to continue our topic statistics. So far we have discussed the different types of the data, what the statistics means and what are the different representations in the statistics by which we represent the data. So far we have discussed the tabular presentation of the data. Today we are going to continue with a few of the numerical examples, and later on we will discuss today the graphical representation of the data. Then at the end we have to discuss the measures of the center tendency. Now let us take the numerical example from the textbook and represent the given data in the tabular form. Now let us see the example. One of the example from our this exercise 14.2 of our textbook. Here the values about the blood groups of the 30 students of the class are recorded as follows. The data is as follows. We are going to write first what are the data values. The blood groups under study were A, B, O, AB, O, A, O, B, A, O, B, A, O, O. And then we have again the blood groups are A, AB, O, A, O, O, AB, BA, O, B, A, B, and the last one is O. These data values you can look at your textbook as well, so that it will give you the clear idea what the data has been given. Now we have to, the question is, represent this data in the form of a frequency distribution table, which is most common and which is the rarest blood group among these students. First of all, we are going to represent this data in the tabular form. Now let us make the table of this frequency table of this data as, here in the variable under study, that is blood group. Then we in the second column we have to draw tally marks. Tally marks. Now let us see. And in the third column we will have frequency. That is number of times a particular blood group is repeated. This is the data about the children of a particular class that has been recorded. Now let us see what are the variables under study. First is A, B, O, and AB. These are the blood groups. AB, O, and AB. These are the variables under study for us. Now let us see one by one. Here the better is to go in the ascending order, starting from the first, that is A here, data value, and go accordingly and go on marking the tally marks, and in this way we will come to know about the frequency of the particular blood group. Now let us see A. It lies in this blood group A, so we had put one tally mark. The method of the drawing the tally marks, it should be clear. It was actually the counting principle that we were using in the olden days. Now these days we rarely use these tally marks, but this was the basic method of counting how many times a particular variable has been repeated. And how we count these? These are counting in the groups of the fives. Like if a particular group is repeated, let us suppose once, we have to put one tally mark. Twice, then second, then accordingly third, then fourth, and for the fifth one we have to cross it like this. In this way we are counting here the blood group in the group of fives. So we don't have to put another tally mark here like this. This is the counting principle that has been used already by the statisticians. Now, it is important to notice here that what was the way used by the statisticians to count the particular variable with the help of these tally marks. If we again draw these tally marks like these, if we cross it like this, remember this thing, this is the right way of counting by the tally marks, and if we cross it like this will be the wrong way of counting by the tally marks. So this needs to be remembered, and this is to be. Sometimes we do the mistakes while counting with the help of the tally marks. Now let us see this come to A. This will be, we have to put here one tally mark, 1. Now come to B will be here, one tally mark. O and O again, 1 and 2. Then AB, we have to put one tally mark here in AB. Then O again, put one tally mark. A, here it will be. O, again one tally mark. B is here. A, here. O. Now already we have counted 4 tally marks, 1, 2, 3, 4. And for the 5th one, we'll cross it like this. And then B, it is here. A, we'll put it here. O, again one tally mark. O, this 2. Then A, we'll cross it like this, complete the 5. AB, put one tally mark here. Then O, another tally mark here. A and A has been repeated twice. 1, 2, 2 tally marks. O and O again. 1 and this will be 2. AB, it is here. Then B is here. A, put one tally mark here in the A. O, it is O here. B will be like this. A, B, and the last one, that's O here. Now let us count how many tally marks here in the blood group of A. How many of the children are there having blood group A? It's 5, 6, 7, 8, 9. 9 of the children of this class have blood group as A. For B, we have 5 plus 1 is 6. Then for blood group O, we have 5 plus 5 is 10, plus 2 is 12. And for AB, we have 3. Now, this is the frequency distribution, tabular frequency distribution rather, that we draw for the given data. And this type of the frequency distribution, as you can see, this is the discrete type of the frequency distribution. Now the question for us is, which is the most common blood group? You can see, you can analyze the table now. Now see the frequency, the maximum number of times a particular group is repeated. You can see here O. O is the most common blood group because it has been repeated 12 times. And which is the rarest, which has been repeated less number of times, and for the frequency is less. You can see this is the blood group A. So the question for us for the given data was, which is the most common blood group, that is here O, and which is the rarest blood group, that is here AB, that is with having the frequency 3. This is how we draw the frequency distribution table. Now let us take one more example for the grouped one. This was the discrete frequency. Now let us take one example for the grouped frequency. The distance in kilometers of 40 engineers from their residence to their place of work were found as follows. The data values are given about the engineers residing from their workplace to their residences. This is the general example that we can take as well for with the help of some of the data values, because this is the real life application, as we also come to our school by our school buses, and we reside at a particular distance, because all of the children in the class, they don't have the same distance from their school to their residence. It varies. Now, if we have taken the values, we have recorded the values of the children of our class. What is the distance from their residence to the school? We can make the frequency distribution table in the form of the grouped frequency distribution. Let us take few values. Let us, in our class, the children, they reside from the school to their residence places, having the varying distances. Let the distances are in kilometers like this. Data values are. This will also clear the question number 2 of our exercise. Here, let us suppose the distance is 2, 3, 7, 8, 6, 10, 11, 14, 15, 16, 17, 18, 19, let us suppose 1 is having the 1 kilometer distance, one of the child from our class, and let us suppose may come from the 15 kilometer, 14, 13, 2, it can be 5, 6, 9, 8, some may come from 20 kilometers of the distance. Let us, these are the distance of the children of our class, which is from their school, from the school to their respective or residential places. We are supposed to find, if we are supposed to make the grouped frequency distribution of this data in the form of the groups starting from 0 to 5. It is given in the example, make the groups in the form of 0 to 5, and 5 not included. 5 we don't have to include here. What does this mean? We have discussed that in the previous topic, that when we don't include the upper limit of the class, that means this type of the frequency is the exclusive form. Exclusive form, that is, this type of the frequency is the continuous frequency distribution. So we are going to make the frequency distribution table that will be grouped. Here we have to make the groups. We'll write in the first column distance in kilometers. This is the variable under study here. These are the distances. So the variable here is distances in the kilometers. Then in the second column we have tally marks. Tally marks and then frequency. Starting from now, how many groups should we make for the given data? It depends on the highest value. Highest value here is 20. So the last value 20 must be included in the data. As such, as many number of groups will be there, so that the last value of the data is included in the group. Starting from 0 to 5, 5 to 10, then we have 10 to 15, 15 to 20, and then we have 20 to 25. These are the possible groups. As the highest value is 20 here, this 20 will be included in this group, last one. Now, these are the groups possible here. Now, let us starting from 2. Now, see the data values in which the particular group in which they lie, 2. You can see it is from 0 to 5, but less than 5. So we have to mark the tally marks for the groups which are included in this group. That means less than 5. Here the 2 will lie in this group. 1 tally mark, 3 again in this, 7 it will be from 5 to 10. Here we have to put 1 tally mark, 8 again in this group, 6 5 to 10 again, then 10. See, the 10, as it is evident now, the 10 here it is less than 10, the values less than 10. This 10 will be included in the next group because this is from 10 to less than 15, that is 10 to 14. So, the 10 will be included here. 11, it will be again included here. 14 will be included here again. 15, now let us see, 15 is here. 15 will be included here in this group because 15 starts from here. 16 again in this group. 17, it will be in this group. 18 again here. 19, we have to cross the tally marks like this. Now let us 1, it will be here. 15 again will be here. 14 is 10 to 15 in this group. 13 again here, we have to cross the tally marks like this. 2, so it is 0 to 5. 5 will be included itself here. 6 is 5 to 10, so we have to cross it like this. 9 will be included in the group 5 to 10, 1 tally mark. 8 will be included in the group 5 to 10. 5 to 10, here 1, and then the last one 20. 20 will be included here. Now let us count the tally marks. The frequency for those, how many of the children are there who are residing within the group of 0 to 5 kilometer range. Now let us see. In this group, the frequency is 4. So 4 of the children they reside within the range of, within the group of 0 to 5 kilometer from their school to their residence place. And then 5 to 10, it is 5 plus 2 is 7 is the frequency for this. Now 10 to 15, we have 5 as the frequency. 15 to 20, it is 5 plus 1 is 6. And then 20 to 25, it is 1. Now you can analyze the table now accordingly. Whatever the question is given in the book, accordingly, maybe how many of the children reside within the group range of 0 to 5 kilometer. So our answer will be at the time 4, as the frequency is 4. Similarly, a number of the questions can be asked about this type of the data. So it must be quite clear now for us to what the table is given for us and the data values we can now analyze. Accordingly, we can give the question answer to any of the question. Now, how many, you can see what you now analyze from the table. You can see majority of the children, they reside within the range of 20 kilometers. There is one child that is that lives within the range of 20 to 25. So we can, in general, we say most of the children, they live within 20 kilometers of the range from their school to their respective residences. This was about the frequency distribution table. Now let us see what we have. What is our next topic now? Our next topic will be graphical presentation of the data. With the help of the graphs, how we present the data. What are the types of the data, graphs that we are going to discuss now. Now, dear children, we are going to start the most important part of this topic, that is graphical presentation of the data. Now let us see first, as it is evident from the word graphical presentation. So we have to represent now data not with the help of the tables but with the graphs. Graphical presentation. Graphical presentation of data. The data can be presented with the help of the graphs. We have 3 ways for this. We are going to discuss that. What are the 3 ways? And then later we will take the numerical examples by which we can understand with the help of the those numerical examples how we can draw these types of the graphs. Now let us first understand what are the types of the various types of the graphical presentations. One is with the help of the bar graph. Keep this structure in mind so that it will be easy for you to understand what is the graphical presentation. Bar graph, then we have histogram. Histogram. In histogram, we have further two types. Histogram of the uniform width. Remember this thing? One is known as with the uniform width. And then the second type of the histogram is of the varying width, where we have the classes that don't have the uniform width. Throughout the groups, the uniformity is not maintained here, of the varying width. Then, third one, that's the polygon. With the help of the polygons, how the data can be presented. For all of these, we use the graph sheets. Better is to use those graph sheets that will give us the exact figure of the data. And we can make them decorative, the graphs, so that it will be attractive for us to represent such type of the data. In polygon also, usually what we do, we have the polygon. Actually, polygons can be drawn from the histograms as well. So, using histograms, with the help of using histograms, one is that, and the another one is without using histograms. Without using histograms. And this graphical presentation we'll see in the numerical examples. It is of the great importance. We use the bar graphs, we use the histograms, we use the polygons, even in our day-to-day life. Like we have sometimes we watch the cricket match and we can see the bars are there for the average, what is the average run rate, and how many wickets fall for a particular hour, and what are the runs that have been scored for a particular hour. And this is the application, real application we can see of the statistics here, the data. Here the application of, because nowadays the statistics is of the great importance. We use in almost every field because the data is to be gathered. If we have the data about whether be it in the health sector, be it in the defense, be it in the games, like we talked about the cricket, we use here these types of the graphical presentations of the data that we have about a particular cricket match. So now let us see one by one what are the bar graphs, how we present this bar graph, the data with the help of the bar graph. We'll take some of the numerical examples from our textbook, and it will give us the better idea how we can represent this data. Now, dear children, let us take one example from the textbook. It will be exercise. It will be our exercise 14.3. One of the example. There are so many examples. Number of the examples there. Based on presentation with the help of the bar graph. Let us take one example. This is question number 3 of the textbook. The question goes like this. Given below are the seats won by different political parties in polling outcome of a state assembly elections. Here we can find the application of the bar graph, how we can present the number of seats won by the particular party in the particular election. So here is the application of the statistics in case of the elections. So we are using here. Now, what are the political parties? First, we are going to write the political parties. Political party. So the variable under study here is for us the political party, and the frequency, that is the how many seats they have won in the particular election. Now, different parties are there. Now see, the political party A, they have won 75 seats. Political party B, 55. For C, we have 37. For D, we have 29. For E, we have 10. And for F, that is 37. For these political parties, we have to draw the bar graph. Now let us see, as we may be aware in the lower class as well, the variable that is the political party here. The variable under study is political party. That we are going to draw along the x-axis. Along the x-axis. So here we will represent along this x-axis the political parties. Different political parties will be there, and along this y-axis, that is the y direction, we represent the frequency, that is the seats 1. And remember, always the frequency is always drawn along the y-axis, and the variable is under study that we draw along x-axis. So here we will draw seats 1. Seats 1. And remember one thing, how to draw the bar graph now. The important point that we have discussed, that for the bar graph, the uniform width must be maintained. And what is the then that way, that method, how to draw the histogram, that we'll see in the next example. But here we are going to draw the bar graph of the first one, that is the political party. We can mark the frequency as 10, 20, 30, 40, 50, 60, 70, and let us suppose this 80. Here we are taking the rough idea of drawing the bar graph, but the exact value you can draw it on the graph sheet. That will give you the exact figure of the bars. So first one is here, the political party A. They have 175 seats. So we'll represent this political party A here with the help of this bar. And 75, in between 70 and 80 lies the 75. Now this is the political party A. This is the bar for the political party A, seats having 75, having 75 seats 1. Now for the B, for the political party B, 55 seats. So it is in between 50 and 60. So the bar will be like this. And remember this thing, this is not the continuous data. Here the data is discontinuous. That is why the common gap is, common width is maintained in between the bars. Now, this was the B, political party B. Then for C, we have 37. So somewhere here it is the political party C. Now, then we have political party D. It is 29 less than 30. So it is about here the value of this party. And this is the bar for political party D. And then for the E, it is 10. They have 110 seats. So it will be the political party E that we are representing. And then at last, the political party F, they have 137 seats. So it will be somewhere here. It is the political party F. Now, this is the graphical presentation of this, the election. The different political parties, they have 1 different seats, and we have represent this with the help of the bars. And you can shade even. Better is to, if you can decorate this with different colors at your home, so that it will be very attractive. And this is the bar graph for the given data. These were the political parties and the seats 1, and this is the bar graph for the given data. This is the graphical, first part of the graphical presentation, that is the bar graph. Now let us see the next one, that is how to draw the histogram. For histogram, remember always, we need continuous data. Continuous grouped frequency distribution we must have. So the continuous data for the histogram is very much important. And if it is discontinuous, then we have to transform the given data first into the continuous form and then use it for drawing the histogram. Now let us take one numerical example to see how we can draw the histogram of the given data. It is question number 4 of this exercise. Let us see what are the data values. The length of 40 leaves of a plant are measured correct to 1 millimeter, and the data obtained is presented in the following table. It is a question number 4 of your textbook, you can see, and the data values are here. The variable under study is the length of the leaf. Length of the leaf. Length of the leaf. Length is in given millimeters. Then we have number of leaves. Number of leaves. Here the data is 118 to 126. Then 127 to 135. Then it is 136 to 144, 145 to 153, then it is 153 to, or it is 154 rather, 154 to 162, then 163 to 171, and then we have 172 to 180. And what are the corresponding frequencies of these groups? It is 3, 5, 9, 12, 5, 4 and 2. We have to draw the histogram of this given data for the leaves of a tree. The length has been measured, and here the variable under study is length. Now, as we discussed that, for drawing the histogram, we need to have the continuous data. Now look at this table. Now let us see what type of the data is. 118 to 126. Now, then from the next group doesn't start from the 126. Here the lower limit is different. Here the lower limit is 127. So the upper limit and the lower limit, they are not equal here. That means this type of the data is of the inclusive form. It is discontinuous form. And with the help of the discontinuous data, we cannot draw the histogram, because histogram is the continuous graph. It doesn't have any break in between. So for this data, certain adjustments are to be made. What are those adjustments? How they are made, so as to make this data continuous. This is very important to understand here, how this data can be transformed into the continuous form. Now let us see how this data can be. This is the important point. For any of the data type which is discontinuous, to make it continuous, let us see what is the lower limit of the next class. That is 127. That is to be subtracted with the upper limit of the previous class. So we have to first find out what the difference is, what are the corrections that are to be made here, and divided by 2. Because the difference which comes for the lower limit of the next class and the upper limit of the previous class, that has to be divided in the 2 groups so as to make it continuous. How we do that? It is 127 minus 126 is 1 by 2, that is 0.5. Now what we have to do with this 0.5? This 0.5 needs to be subtracted from this lower limit, that is 0.5 will be subtracted here and added back to this, the upper limit. We have to add back 0.5. In this way we can make the groups continuous. Now let us see here the length. Length is 118 minus 0.5, it will be 117.5 to 126.5. Now if we subtract 0.5 from 127, it will be 126.5 and add it back 135.5. Now you can see by looking at these two groups that we have transformed in some other form. Here the upper limit of the first group, that is 126.5, is equal to the lower limit of the next group. So accordingly we have to subtract. It will be 135 here, 135.5, and then 144.5, then 144.5, and then we have 153.5, then again 153.5 to 162.5, then it is 162.5 to 171.5, then the last one 171.5 to it is 180.5. Now we have transformed the data in the continuous form. Now we are going to draw the histogram of this particular data. Now let us see how we draw the histogram of this data. Here the data values start from 117. So we can start the data values from the 117, 117.5, and then here directly we cannot jump to the 117.5, but there is a graphical representation with the help of which we show that all those values before that are included. This is the graphical presentation. What we call this? This you must be knowing that this graphical presentation before 117.5, that is known as kink. This is the kink of the graph, that all those values are included before 117.5. Then 126.5, it is 126.5, then it is 135.5, then we have 144, 153.5, 162, and the last one, then it is 171.5, and the last one is 180.5. These are the groups now for which we are going to draw the histogram. Now the first one, the frequencies are the maximum value, highest value is here 12. So we can make the groups in the form of 1, 2, or as you like. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And this, you know, this is the length in mm, this is the variable under study, and this is the number of leaves accordingly. That's the frequency, number of leaves. Now for the first one, 117 to 126.5, we have 3. It is 3 is here, 3 is here, then it is 5. So we have to continue now. In the bar graph, we were drawing the next bar with the gaps. Then we have 9 here from 135.144.5, then it is 9, then it is 12. Next one is having 12, then it is 5, then it is 5, then it is 4, and then the last one, that is 2. This is the histogram of the uniform width. As we discussed in the introduction part of the graphs, that the histogram can be presented when it is having the uniform groups. Uniform width is maintained throughout the groups. And then the next part of it, the histogram, will be the histogram of the varying width. In the next part of this lesson, we will discuss how we can draw the histogram of the varying width, and then we have the polygons. Polygons can be drawn from the histogram as well and without using the histogram. If we have to draw the polygon, let us take the idea that this is the histogram now. This is histogram. And if we have to draw the polygon out of this, then we have to take the midpoint of the tops of these. These are the midpoints of the top of these bars of this distribution. Then what we have to do? We have to join these midpoints. If we are supposed to draw the the polygon of this data. So the first type of the polygon, that is by using the histogram. This is how we can. Now the end values, where we have to join these. Now we have to add one more class before that and after the rectangles. These classes, let us suppose this is the midpoint of this class. And this is the midpoint of this class. These two classes which we add before the start of the rectangle and after the end of the rectangle. Remember, these two classes, these two groups or the intervals are known as imagined classes. We imagine these classes that they are in the given frequency there. And this is how we can draw the polygon out of the histogram. So first of all, what we need to do? We need to draw the histogram as we did, and then take the midpoint of the tops of the bars, and then after we have to join these tops, midpoints of this, and this is how we can draw the polygon. That was all for today's lesson. Here we discussed the histogram as well, and in the next part of this topic we'll discuss how to draw the polygon and the histograms of the varying width. And at last we have the small topic, that is the measures of central tendency. Thank you very much for today's lecture.